Welcome to The Explainer. Today, we're diving deep into what happens inside your brain when it encounters different substances. We're going to break down the neurochemistry behind everything from your morning coffee all the way to the razor's edge of a lethal overdose.
You know, it really all comes down to chemistry. Specifically, it's about how different substances can either hijack, mimic, or just plain block the brain's natural messengers. This is a story about signals, receptors, and a really delicate balance that can be thrown into chaos fast.
So, before we can even begin to understand the effects of any drug, we have to understand the brain's native language, and that language is neurotransmitters. Just think of them as tiny couriers, zipping around delivering messages that control pretty much everything: how we feel, how we think, and how we function. Okay, let's start with the chemicals that basically put the central nervous system into overdrive. These are the stimulants, substances that hijack the brain's pathways for reward, for energy, and for focus. They essentially turn the volume all the way up to 11. So instead of the normal, regulated little burst of dopamine you get from, say, eating a fantastic meal, these substances unleash an overwhelming flood. It's this incredibly powerful, euphoric rush, right? But it's happening because the brain's delicate chemical machinery is being forced to work in a way it was absolutely never designed for. Now, here's what's so fascinating about the mechanism. Stimulants don't actually create new pleasure. What they do is they trap the dopamine that's already been released. They block the little cleanup crew, these transporters, from doing their job. So the dopamine just builds up and up in the synapse, that little gap between nerve cells, and it just keeps hammering those receptors over and over, creating that intense but totally artificial high.
All right, let's completely flip the script and move to the opposite end of the spectrum. Let's see how depressants work. If uppers are like jamming the accelerator to the floor, while downers are about slamming on the brakes of the central nervous system.
So our brains have this natural braking system, and it's called GABA. It's the chemical that tells our neurons, hey, slow down, fire less often. It's what keeps us from being in a constant state of panic. Depressants don't invent a new brake pedal. They just find the one that's already there and make it way, way more powerful. And this process right here, this is what leads to dependence. When the brain is repeatedly hit with this artificial calming signal, it adapts. It starts to rely on the drug to feel calm, and it kind of forgets how to regulate anxiety on its own. That's exactly why withdrawal from depressants can be so incredibly severe. You get this rebound anxiety and sometimes even seizures.
So the crucial point here is that we're looking at two totally different strategies for messing with brain function. One creates way too many go signals, which leads to all that energy and euphoria. The other one amps up the stop signals, leading to sedation. But in both cases, they create a state the brain will fight to get back to, and that's what drives the whole cycle of use.
Okay, so now let's talk about a class of substances that do something else entirely. These don't just turn the volume up or down, they fundamentally change the song. They change the very nature of perception and consciousness itself. You see, these substances play with completely different systems. On one hand, you have psychedelics like LSD. They latch onto serotonin receptors, which help shape how we see the world. Suddenly, reality can feel like it's breathing or dissolving. Then you have dissociatives. They block glutamate receptors, which essentially disconnects your mind from your body's sensory input. And that leads to that profound out-of-body feeling. Now we need to get serious and examine the clinical data, because when these chemical interactions are pushed too far, the consequences can be, well, catastrophic. We're going to look at the pharmacology of an overdose and really see what makes certain substances so incredibly dangerous. For so many of these substances, especially the ones you find on the street where you have no idea what the purity is, the difference between the desired effect and a fatal outcome is just shockingly small. And I'm not talking about grams, we're often talking about milligrams. So to put 30 milligrams in perspective for you, that is less than the weight of a common housefly. For somebody who doesn't have a tolerance, that tiny amount can be enough to slow their breathing down and then stop it completely. With PCP, the danger zone gets even smaller. We're talking about the weight of a single grain of rice. At a dose like that, the risk of seizures, coma, and death becomes incredibly high. It just goes to show you the potency of some of these synthetic chemicals. And then we get to fentanyl. 2 milligrams. That's like a few grains of salt. This stuff is so powerful that a microscopic amount can shut down your body's respiratory drive entirely. There's a reason this is at the heart of the overdose crisis. This quote from one of our sources just
It really puts it all into perspective, doesn't it? It highlights the terrifying reality of fentanyl's potency, and it explains why accidental overdoses are so tragically common when other drugs are unknowingly laced with it.
And it's not always the same thing that goes wrong. Stimulants like cocaine often kill by just overworking the cardiovascular system until you have a heart attack. MDMA can cause this catastrophic overheating, but with opioids like heroin and fentanyl, the cause is tragically, brutally consistent. Respiratory failure. The brain just forgets to tell the body to breathe.
So, after being put through all these chemical extremes, what happens when the brain tries to find its way back to normal? The road to recovery is a biological one. It's the story of the brain slowly and painstakingly rebuilding itself from the ground up. You have to understand, the brain is a master of adaptation. When it's faced with a constant flood of dopamine, it just starts removing its own receptors to protect itself. When it's faced with constant artificial sedation, it dials down its own calming systems. These aren't moral failings. These are purely physiological adaptations. The brain is just trying to find balance in a world that's become chemically unbalanced. And this right here illustrates the result. A dependent brain has physically changed. It has fewer receptors, it has lower production of its own natural feel-good chemicals. This creates a constant state of deficit, and that is what drives the cravings. So when you compare it to a baseline brain, the goal of recovery becomes really clear. It's not just about willpower. It's about giving the brain the time and support it needs to literally rebuild its hardware and get back to that baseline. This incredible ability of the brain to rewire itself, what scientists call neuroplasticity, it's really a double-edged sword. It's the very mechanism that allows addiction to take hold in the first place, as these pathways get stronger and the chemical baselines get reset. But it's also the exact same mechanism that makes recovery possible. It's the ultimate proof that change is always possible, that the brain can heal, it can relearn, and it can find its way home.